All right. Hello and welcome. We're so excited to get started with our workshop on quantitative linguistics methods. Thank you so much for joining us. As we get started, a couple of quick things to note. If you follow these instructions here on this first page, you can get your Zoom window set up so you can see both our slides and us in the speaker view. And then also, if you would like to anonymize your Zoom username, you can follow the last bullet point instructions to click on the three dots and rename yourself to whatever you would like. And with that, we're going to go ahead and get started. So our tentative schedule for today is we're going to have a brief welcome with some general information. After that, we'll have part one covering research design and sampling. We're going to have a lunch break starting at 11:45, and these are all in Pacific Daylight Time or Arizona time if you need to do some conversion. Most of you will. After that, starting at 1 o'clock Pacific Daylight Time, we'll start with part two on R, descriptives, and data visualization. Part three covers p-values, effect sizes, and confidence intervals. And then we'll have time at the end for questions. And you're more than welcome to be asking questions throughout. If you send a direct chat message to the Ask Questions Here account, we'll try to get back to those just as soon as we can. Okay, here's a map showing where our participants hail from. We have people tuning in from 36 different countries, and we've got quite a bit of international, global participation here, and we're really excited about having all of you join us. So a little bit more about you, just to give you a sense of how much variation there is in the participants who have signed up for this workshop. We have people from a wide range of different professional positions. Fields of research, we have a little word cloud here showing what you listed as your current field of research, and we're covering quite a bit of the spectrum of different areas within linguistics and applied linguistics and some other areas as well. In terms of background knowledge related to statistics, people listed themselves as having everything from none all the way to advanced, and we hope to be able to appeal to people from a range of backgrounds today. Familiarity with R, our second segment will cover R, and we have a wide range of backgrounds there as well. Some brief recommendations from us. Because we have such a wide range of previous knowledge related to statistics, R, and research methods, we will do everything that we can to make sure we're explaining concepts and principles, not assuming a lot of previous knowledge. However, if we're using terms that you're not familiar with, you're again more than welcome to send a direct message chat to the Ask Questions here, and we'll try to get back to you as soon as we can. If you're having any problems with the streaming, you can also chat us there. But keep in mind that we are recording this, and you'll be able to get the video after the workshop is finished to rewatch or to watch if you have any trouble during the workshop itself. Again, feel free to ask questions if you find the material to be a bit too difficult and you have specific questions. And if at times you feel like you're in the more advanced group and feel comfortable with the material being covered, sit tight. There will be more advanced things to come, and we really hope that everyone will walk away from the workshop today having learned many new things. So with that, I'll turn it over to Tuve, who's going to give you a bit more information.
today is provide an overview and an introduction to some areas of interest to quantitative linguists like yourselves. And that means that we will introduce and thus not fully cover concepts or and thus invite you to learn more about that are of interest to you. So what we won't be doing is to provide an in-depth coverage of the concepts and tools provided because we have so much time. One day we will have 2 hours each.
Sova, can you speak up? We can't hear you.
Let me see. Can you hear me now? Okay. No?
Well, the same thing happens if we're not listening that well. Sorry.
Okay, let's see if this is better. Yes, very good. Okay, so let's briefly, just in case you didn't hear what I said here, just a few words. We will give an introduction to some areas, but we will not be able to give you any kind of in-depth coverage of these concepts and tools provided because we only have so much time. We only have 2 hours each. So we'll have to direct you into other, we have, for example, some books here that you might want to look at instead. Thanks. And so our aim here is to kind of open up some doors for you to show you that there are these metaphorical rooms where you can find more information and more knowledge of different kinds. And then you'll hopefully be able to properly walk into these rooms and learn more about what's in there later on once you have this introduction from us. And we're hoping to also be able to have some more online webinars, so keep an eye out for more information coming from us. 2 things about what's going to happen after the workshop. So instructions for how to access the video will be sent out by Monday. And we'll also send out a course evaluation. We would really, really appreciate it if you could take some time to read through and answer those questions for us. It will be questions about the workshop today and also about potential future workshops that you might be interested in attending. And Jesse already covered some of this, but just to make sure that things run smoothly today. So we would love it, of course, if you could all be here in the room with us, but because of all that's going on, that's not possible. So this is an online workshop, of course, which means that there might be some technical issues on our end and maybe on your end, and hopefully everything will go smoothly, but just to make sure that things go as smoothly as possible. If you have questions about the content, we'll have time for a Q&A, question and answer session at the end of the day. But note that we won't be able to answer any questions other than questions that have to do with the material that we've actually covered today. So if you have questions about technical issues, Zoom, the streaming, please use the chat function that Jesse mentioned. Please write to ask questions here, and that way you don't have to send it to everyone, and we'll try our very best to help you. And should there be a problem that can't be solved somehow, then we will have the recording available for a week after the workshop, so you will be able to go back to that. And so no stress. And if you have questions about the workshop in general, the first step would probably be to check out our frequently asked questions tab on our website. You can also go to our Twitter account. Our handle is Quant Linguistics Methods, linguistics abbreviated LX. And with that, I'm going to hand over to Luke.
Hey, everybody. I'm so glad you're here. So a few sort of introductory comments kind of on the conceptual side. A lot of today's discussion throughout the course of the workshop is going to be kind of in some ways balancing both conceptual notions as well as the more practical hands-on stuff. And so I think that methodological training, and that's what these introductory comments are about, really about kind of our philosophy on the use of research methods and training of research methods. But methodological training, which is something that I spent a lot of my professional time working on, has to balance these things, has to balance both the conceptual side of things as well as the practical. If we don't have the conceptual, we're not going to have a clear rationale and justification for why we do the things the way that we do them. So first kind of bullet about on our kind of philosophy of method of use and of training of research methods is a really basic idea, and that is simply that methods matter. We as a field, as researchers in linguistics, we need to take our methods really seriously. And maybe that's obvious, but we don't necessarily have a long methodological tradition, or a tradition of methodological expertise in the field. And it's our position, and one of the reasons that we're putting on this workshop is that we as a field cannot advance. We can't inform the stakeholders, the constituents that we care about, the people that care about theory and future research and practical issues as well. We can't address or inform any of these areas if we don't have sound research. We're doing high quality research, high rigor, adhering to principles and standards, and great transparency. So that's kind of what we mean by methodological quality. So methods really matter. If we're not carrying out research that is of high methodological quality, what's the point, right? So that's one of our kind of motivations here. Along with that, though, I think it's worth recognizing that there's no such thing as a perfect study. Every study has built into it certain kinds of trade-offs, things that make it strong, but they may also present limitations in other ways at the same time. And so that's sort of a kind of a starting point, a point of departure, an assumption that we take into this discussion as well. And along with that, so along with that idea that there's such thing as perfect study and these choices that we make, that statistics and quantitative methods, and maybe even you could say research methods in general, can be considered in many ways both an art and a science. And what I mean is that, again, we have so many choices, and so and all these choices again involve these trade-offs. So just think about, for just as one example, the choices that we make in terms of experimental control that maybe we get in a laboratory-based study versus what we might call ecological validity, which is more available, that sort of authenticity to the real world that we get from carrying out a classroom-based study. So the idea is not to do perfect research, because there's no such thing. The idea is to make choices along the way that adhere to and that are standards of rigor and transparency, and that will maximally inform the domains that we care about. Along with this as well, I want to encourage you guys to think about developing methodological expertise, and to know that doing good research requires not only a knowledge of the substance, that's the what, that's your topic area, and as we just saw a couple minutes ago in that word cloud, that we come from lots of different areas of linguistics, but we also have to start to of course, develop and start to see ourselves as having expertise in methodology as well, and that's what we're working on. I'll also say that there are times, today our focus for today is really on the basics, and so if you're new to quantitative methods, or if you feel like there may be some gaps in your methodological knowledge for the basics, or if you need a refresher on some of the basics, you're definitely in the right place. There is though certainly occasions when more sophistication is needed, and hopefully we'll get there. Not today, but we're sort of all on this path. But our position for the three of us anyway is that more often than not, a kind of less is more approach is best. So we take a kind of, with the APA, American Psychological Association, what they refer to as minimally sufficient approach to quantitative methods. So we're not trying to overly complicate things. Our position is, for the three of us, we are all, we really love good descriptive statistics, good data visualization, strong research design, these fundamentals, because everything else sort of builds on top of that. We all like stats. but we're not all about sort of making things more technified just for the sake of technification. I'll also say that there's always more to learn. So every time I teach a workshop or a class on research methods, or I pick up a new book or read another article, I'm always trying to advance my knowledge, and I would encourage you guys to do the same. To collaborate with people in other disciplines who might have different methodological perspectives, post questions on different forums, explore other methodological approaches, reanalyze a set of data to try and maybe come at it from a different angle. And I think we get new knowledge from that. We want to also encourage you guys to think about developing expertise. Both, I think everybody who identifies as a quantitative researcher in linguistics should have a kind of breadth of knowledge. And again, that's one of the goals of this workshop, is to make sure everybody has these really core fundamentals of quantitative research in linguistics. But also, we've encouraged you guys to consider developing in-depth expertise. And that's not what today's workshop is about, but we think it's actually really good and healthy for the field to have in-depth knowledge, and to have more people kind of sprinkled around the field that have really in-depth knowledge. I think that's sort of good for everybody involved. And then also just that we would encourage you guys to think and act as a community of researchers, and we might refer to this, and I'll talk about this a little bit later. Thinking and acting synthetically. By that we mean working together and not thinking of any individual study as being the conclusive answer to any question that's worth asking. And so some of the ways that we do that are through transparency, through replication research, open science practices. We'll talk a little bit about these. Synthetic mindedness more generally, building up, not just out into new territory. So with that, I will step off. Thanks so much. I'll be back with you guys. And my part is going to be towards the last session. But looking forward to see you guys. Thanks so much for being here. And with that, I will hand you over, put you in the very capable hands of Dr. Jesse Egbert.
Okay, hello again. So that covers the introductory information that we wanted to share with you, and now we're going to dive into content. Again, we're so excited to have you here. My portion of this will be for the next 2 hours, and I'm going to cover principles of research design as well as sampling. So when it comes to research design, I think of all of the practices that we follow, in particular when we're planning out a study and thinking about how every step of it will proceed before the study even takes place, but it also incorporates stages of the study itself. And so we'll get into that. The second stage for probably the second hour or so will be focused on how do we achieve generalizability in our findings through appropriate sampling. How do we take data from a sample and try to extrapolate, generalize to, and learn about population that we actually care about. Okay, so we're going to take a big step back from applied linguistics and think a little bit about what science is on a very general scale. Applied linguistics I see as a branch of science in the scientific enterprise. So I'm going to include some quotes here. And information from the American Association for the Advancement of science. Science obviously uses the scientific method. This is foundational to everything that happens within the scientific community. In essence, scientists respond to claims of truth or fact by asking what evidence is there that supports those claims. And evidence comes as a result of the scientific method. Science relies on data. It's empirical, and the goal is to test hypotheses. Importantly, these hypotheses are falsifiable. We'll talk about this in more detail in just a moment. But this quote here says, a hypothesis that cannot, in principle, be put to the test of evidence may be interesting, but it is not scientifically useful. If we cannot learn that a hypothesis is false, then we can't ever learn anything about its truthfulness, and it's not interesting or useful, at least within the scientific paradigm. And then it's important to point out that science can be observational or experimental. A lot of times you'll see in maybe research design or statistics books, they sort of elevate experimental research designs above observational. And in some ways, experimental designs are really powerful. They allow us to control for variables and make claims about causality that we can't make claims about with observational data. However, that does not mean that observational data or the observational approach to research is not scientific. If that were the case, then astronomy would not be science. And yet it is. We've never performed an experiment on a distant star, and yet we learn about the cosmos all the time through our observational data. With that, we'll start zooming in a little bit on some of the questions that were raised probably within that last slide. So what is hypothesis testing and why are hypotheses important? Well, if we go clear back to Sir Ronald Fisher, he talked about the importance of trying to falsify a hypothesis hypothesis. Now, he didn't use the term falsifiability, but he was in the very early stages of saying what we really need to be able to do is try to accrue evidence against a hypothesis by seeing if that evidence passes some pre-established threshold. And if it does pass that threshold, then we will conclude that the hypothesis itself must not be true. We fast forward a little bit and we get to Nyman and Pearson, who talk about hypothesis testing in the form of numerical quantitative probability. And this is where we get the idea of a null hypothesis and an alternative hypothesis. And this will come up throughout the day. But the null hypothesis is the one that makes fewer assumptions. It doesn't posit any relationship among the variables, and it basically says that nothing is happening. In the data with regard to a particular variable. The alternative hypothesis says that something is happening and that there is a relationship, and it makes more assumptions. But this is what we're testing. And then Karl Popper, really importantly, came along and championed the principle of falsifiability and said that the backbone of the scientific enterprise is falsifiability. In essence, this says that we never prove that something is true. Rather, we work through process of elimination. We can show through data that something is false, and that helps us to narrow something down to a narrower scope of possibilities. But we haven't yet found truth and fact. We're just narrowing down the scope. Having found an absence of a relationship does not necessarily lead us to conclude that we found the answer, because there could be certain things that we have not yet tested and therefore haven't yet put to the test of falsifiability. So let's look at hypothesis testing with an example. And this example asks the research question, are there cats in the park? So we have a park that we're thinking of. And we want to find out if there are any cats in the park. We have a null hypothesis that says there are no cats. We make no assumptions and say that by default we assume that there are none. The alternative hypothesis says that there are. And then we have some sort of critical threshold at which we'll decide that there are cats in the park. This starts with us deciding what do we accept as a cat, what will count as we measure cats, and then we have to decide how many cats will be enough cats to reject the null. This is a very simple hypothesis. And so in this case, even one cat should be enough to falsify the hypothesis that there are none. So there are no cats in the park is falsifiable. We can actually test that by going in and seeing if we can find any. So if we flip it around, and if we say that there are cats in the park is our hypothesis that we're testing, the question is, why is that not falsifiable? And in fact, it's not, because simply not finding any cats in the park doesn't provide conclusive evidence that there are none. Cats are elusive, and it could be the case that we just didn't see any or observe any, even though there are in fact cats hiding somewhere in the park. So it's much more difficult to falsify the hypothesis that there are cats. And saying that there are none simply says that there's an absence of evidence, and as we know, the absence of evidence does not constitute evidence of absence. So let's look at another example of a hypothesis or a theory within linguistics that has trouble with the principle of falsifiability. If we look at universal grammar, there's a number of hypotheses that are posited within this framework. I'll just mention a couple. One is that certain grammatical structures follow these universal rules in human language. However, just because we haven't yet found an exception to a particular proposed rule doesn't necessarily mean that exceptions are impossible. After all, we haven't yet documented in an exhaustive way every single language that exists. And even if we had done that, that still doesn't show that something is not possible. It just says that we don't currently have a language where this is verified. So it falls into the fallacy of absence of evidence does not constitute evidence of absence. Another hypothesis from universal grammar is that the grammatical rules I just mentioned are biologically pre-specified. They're part of our DNA, essentially. However, just because all known human languages follow a particular rule doesn't necessarily imply that the cause of this is biological. Sure, we all have certain traits that are inherited genetically because we're human and living creatures. And we may all follow this rule, and that's a correlation, but the causal relationship isn't actually demonstrated through the data itself. So this is a different fallacy. Correlation doesn't imply causation. But in both cases, universal grammar is artificially insulated from scientific falsifiability. It actually proposes hypotheses that cannot be tested. and cannot be falsified. We don't have any scientific way of finding that they're false. Therefore, science can't help us to ultimately decide how much evidence there is for their truthfulness. So it's pseudoscientific, and this worked well for Chomsky. He was a rationalist, and for most of his career didn't spend a lot of time within wasn't particularly interested in the empiricist paradigm. But now that empirical linguistic research has come to the fore and is dominant in many ways, we need to remember that some of the theories that we've used in the past may have some fundamental problems that make them difficult to test scientifically. Okay, so getting back to our example, the evidence that we need in order to test our hypothesis comes from the observations that we'll make about cats, essentially looking in the park to see if we find any cats at all, and we need to decide on how we'll measure catness and so on in animals that we observe. Okay, so having that foundation of the scientific method and falsifiability and hypothesis testing, we're going to move forward and talk about various steps and stages in the research process. So we'll start very basically with establishing a research question or a research goal, and then move into developing the research design for our study. Now keep in mind, all of this is happening before we even go out and collect data. At this point, we're designing, planning, and laying out a study, not necessarily collecting data just yet. So we need to design a representative sample. We need to make decisions about how it is we'll go about collecting our sample, and I'll have the second segment devoted to that. We also need to make a decision about our unit of observation. What is it that we'll be measuring? And then our variables, we'll talk about in a few moments, come in different types and different levels and different scales, but these are the phenomena that we're measuring and trying to learn about on our units of observation. Once we've laid out those design decisions, we can start to think about statistics. Note that we've done a lot before we've even gotten to the point where we're thinking about statistics, because selecting an appropriate statistical method hinges on the research design that we're working with, not the other way around. Once we have decided on the most appropriate statistical method, we test assumptions for that technique, make sure that our data meets the assumptions that are required by the statistical method. We can run the statistics and analyze the results. Interpret the results and present our results in some form, hopefully in writing, so that we can share our findings with the research community. Interestingly, again, we often think about statistics first and foremost, but there's so much that happens before we should begin thinking about statistical methods. Statistics are a tool that can be used to help us to make sense out of our data, but they're only a tool, and they shouldn't be driving the whole enterprise. They should be used as a tool to help us with answering the questions that we've laid out from the beginning. So we'll come back to each of these steps in this segment. Okay, so your research questions are the key questions that you're aiming to answer in the current study that you're working on. Ideally, these are laid out in advance and they drive everything that follows. I have a colleague who tells all of her students to write out their research questions on a sticky note, paste them to the monitor of their computer, and always remember what are the questions that are driving this research so that we don't get lost in the weeds. And as we'll see in a few moments, there are so many decisions we have to make that we could lose track of what we're doing if we don't remember what is the enterprise, what is the question that we're trying to answer in the study at hand. These questions should be motivated by previous research, by us or others, also by practice. I'm always so excited to see students who come in and say, I have a burning question, and it came about when I was teaching or talking with my students. I think applied linguistics is so wonderful because many of our questions are driven by practical questions, often ones that will greatly benefit people if we can find answers to them. And then, of course, theory. We have theory in our field and much theory in the broader field of linguistics at large. And theory can give us a useful starting point for our research, give us something to test, and help us to be informed in our interpretation of findings once we have them. Research questions need to be answerable. Relating to the discussion about hypothesis testing and the scientific method, we need to make sure that it's possible to collect data and to analyze that data in such a way that we can get answers to our questions. This means research questions often take a great deal of time and effort to refine. We need to make sure that the question itself is articulated in such a way that you could provide an answer to that question that would be satisfactory. And then we advocate for asking questions that are framed around to what extent, rather than is or does something happen. So instead of saying does age affect the learning of X? It's better to say, to what extent does age affect the learning of X? We'll talk in a few minutes about how variation is everywhere. And it's not enough to simplify that variation down to a yes or no response. That could be helpful, possibly, but it's so much more interesting to go further and to actually explain what the data shows, and that will come in the form of to what extent answer. Is there a relationship between test scores and motivation? I think it's better to say how strong is that relationship, because again, relationships are measured in degrees, not in yes or no. And the real world is continuous in nearly every case. And so representing that continuous nature of the real world through our questions helps us to get off on the right foot and can drive the types of answers we'll be able to get from our data. And then I think it's important to think about the questions that need answers, not just the questions that we can currently answer. oftentimes we'll think about the questions that really matter and maybe find that our current skill set falls short. And that can feel discouraging, but remember, if it's a question that needs an answer, then it's probably worth the effort to try to develop the skills in order to answer it, or to find a collaborator who can join the project and bring additional skills. I've noticed anecdotally a trend in our field in the direction of more co-authored work, more collaborative research, and I think that's exciting. I think in many ways that shows that the field is maturing in its use of empirical methods and the scientific approach, because it's requiring that often that people from different backgrounds with different sets of skill sets and possibly different theoretical orientations are working together to solve the same problem. Obviously, some questions cannot be answered right now with our current methods. But many can if we will put in the effort to try to learn what we need to and to maybe work with others who have a different skill set than our own. Okay, so we've got our questions, and now we need to think about what it is we're taking measurements on. And our unit of observation is really important. It's something that we don't talk about a lot, but it's crucial that we understand what it is we're taking measurements on, because it's ultimately that unit that we're learning about. So the unit of observation is typically the same as the sampling unit. The unit that we collect one at a time into our sample is it's often the unit of observation, but not always. These often make up the rows in our data set. So for example, we often use people or participants as units of observation. These are test takers or students or listeners or study participants. In corpus linguistics and discourse analysis, we often use texts. So individual textbooks, individual academic articles, blog posts, and tweets could be individual units of observation. But then within corpus linguistics, we often have other units of observation, including things like words. What's important is knowing what your unit of observation is, and that will help you to understand what it is that you can make generalizations to. If your unit of observation is a person, then your results will be generalized back to people. If it's a text, then your results will be generalized back to texts. Okay, so variables. This is something that we talk about all the time. This is a really commonly used word in empirical research circles, but we're going to try and remind ourselves at least of a few of the fundamentals of variables, the different types of variables, the different scales they can be on, and how that understanding can help us to ultimately make decisions about the statistical techniques that we'll need to use. So a variable is any characteristic of the observational unit that can be measured or described, and that these characteristics vary, hence the word variable. These usually make up the columns in a data set. So we have different types of variables. We've probably all heard of independent variables and dependent variables. It can be difficult, I've learned, when you're first exposed to these two words, to keep them separated in your mind, which is which. The most important thing for beginners is knowing that there are two different types of variables and that they're different from each other in important ways. And I think then you can try to commit to memory which one is independent, which one is dependent. The independent variable is often referred to as a predictor variable or an explanatory variable. The dependent variables are often referred to as response, criterion, or outcome variables. Okay, for independent, this is a variable that's used to explain or predict the dependent variable, hence predictor or explanatory. It's important to note that the values of the independent variable don't depend on the dependent variable. Rather, we're testing to see if it's the other way around, but they're independent of anything that's going on with the dependent variable. And these include attributes such as age, sex, L1. In corpus linguistics, they may be register, dialect, and so on. Dependent variables or response, criterion, or outcome variables are what we're actually measuring. It's the outcome or the output variable that we're trying to learn about. We are predicting in our research that the values of the dependent variable will depend on the values of the independent variable in some way. And these are measurements taken on the observational units. And these measurements could be test scores, word frequency, or response times. Okay, so shifting gears a little bit, but still talking about variables, let's talk about the different scales that variables can be measured on. So we can have nominal or categorical variables. And these are factors that have multiple levels, but there's no numerical ordering to the levels themselves. Things like whether you're an L1 or an L2 speaker, your first language background, your sex or the register for a text. These are variables that have multiple levels, but the ordering of those levels doesn't matter. It doesn't have any meaning. So if we think about different registers in a corpus study, we may have the register of conversation and the register of academic writing, but whether we look at conversation as the first level and academic writing as the second, or the other way around, it doesn't make any difference. They're just separate levels of the same variable. Contrast that with the first numerical variable that we'll talk about, which is ordinal. And in ordinal variables, these levels of the variable have an order to them. The numbers mean something because they allow us to rank order the variables in some way. So think of Likert scales or other types of human ratings where we believe that a 5 is greater than a 4 and a 4 is greater than a 3 on this scale. However, the difference between these levels is not necessarily equal. We can't assume that just because we have a rank ordering to the levels of the variable, that we necessarily have equal gaps between the levels themselves. That's something that we don't know. And so in some ways, ordinal variables limit us in what we can learn, but they turn out to be really powerful, especially for measuring human perceptions, human responses, human ratings. Okay, so going a step further in the direction of quantitatively measuring real-world phenomena, we have continuous variables that can take any real numbered value, and the difference between these levels we can assume to be equal. We have two different types of those. So both of these types, the difference between the levels of the variable are equal to each other, those gaps. However, the interval scale has no true zero. So think of something like temperature. That can go in the negative direction. Zero is an arbitrary point that we've overlaid on top of the construct of temperature, but we can go in the positive direction or in the negative direction. And zero is, we can be on different temperature scales. Zero itself doesn't have the same meaning as it does in a scale variable where we have a true zero. Things like years and weight, where 0 years means no time has elapsed. 0 weight means there's no amount of weight that's registering on the scale. But for both of those, they cannot go in the negative direction, and 0 is not arbitrary, rather it means something concrete. And it's important to understand the difference between these variable scales because these often determine the types of statistical techniques that can be used with your data. None of them are necessarily bad or problematic. They're just different from each other, and they allow us to learn different things about our data. Okay, so now we're moving a step forward to talking about selecting an appropriate statistical method. So I love this quote from Michael Crawley. He says, "Because everything varies, finding that things vary is simply not interesting. We need a way of discriminating between variation that is scientifically interesting and variation that just reflects background heterogeneity. That is why you need statistics." So according to Crawley, statistics help us to distinguish between signal that we care about, that's showing us something about our data, and noise, which is just variation that's either unexplainable by the variables in our study or just random noise. There's a book by Nate Silver titled "The Signal and the Noise." And a major theme of that book is how statistics and big data and other scientific approaches are all geared towards making the distinction between signal that we care about and noise that's, for all intents and purposes, random. Simply finding some difference or some relationship does not allow us to conclude that what we found is meaningful. It could be random. It could be simply noise in our data. And we want a way of discriminating between signal and noise, and statistics allows us to do that. So here are some considerations that should come into play when you're deciding on the most appropriate statistical method. The research question or aim that we've talked about, what your unit of observation is, what is the type of variable that you'll be including, dependent, independent, what are those, and then how are they measured, what are their scales? And often the independent variable and the dependent variable have two different scales. In a one-way ANOVA design, the dependent variable or the response variable is continuous, is maybe a scale continuous variable, and the independent variable or the predictor variable is categorical or nominal and has multiple levels. And understanding that the dependent variable is continuous and that the independent variable is categorical is an important starting point to knowing that ANOVA is the appropriate statistical design to answer your research question. And then it's important to be thinking about your sample. Depending on the sample you have or are able to get, you often have a different range of choices about the type of statistical method that you can or should be running. And I'm not just talking about the size of the sample, but also the nature of the sample and what it represents. And then it's always good to think about your audience or your stakeholders. Before we began, Luke talked about taking a minimally sufficient approach to statistical methods. This becomes even more important when your audience is maybe lay readers or practitioners who are not themselves quantitative researchers. It becomes really important that we don't use statistical techniques that are more advanced or sophisticated than we need to be able to show the patterns that are important for our audience. Really, it's about choosing the most appropriate method, one that is sophisticated enough to answer our question, but doesn't have additional levels of complexity and sophistication. And our audience can help us to answer that question. And sometimes the data that you present to your audience will depend on who's in the audience. So you may publish a peer-reviewed research article using statistical modeling, and then you may give a talk to some teachers on that same study, and you may choose to simply report descriptive statistics because you know that they'll understand the mean, maybe some measure of variance, and other ways of looking at the data, and it's not necessary for that particular audience to be giving them additional statistical tests. So audience plays an important role. Okay, so when it comes to statistical analysis, we have a lot of options. Here is a decision tree for univariate statistical methods. And you can see that we already feel kind of dizzy. Now, I'm not going to be going through all of these today, but you can see that depending on the type of variable on the left-hand side, whether it's categorical, we just talked about, or continuous, interval or ratio, we'll go down two different branches of this decision tree. And then if we go within the interval or ratio branch, we ask, what is the type of question? Do we want to learn about relationships or associations at the top? Or do we want to learn about differences between groups at the bottom? And then we branch out based on how many predictors or how many groups and so on. And you can find yourself down at the very end of one of these nodes with a suggested technique that would fit all of the decisions that were made. But in order to get to that point, we have a dizzying array of options in front of us and choices that have to be made. The better we understand the research design that we're using, the better equipped we'll be to find ourselves successfully at the end of this with the right statistical technique. And throughout the day, we'll be talking a bit more about these types of choices and hopefully equipping you with the information you need to be able to get to that point. Okay, so some of you may find yourself confused about statistics, as I often do. I can sympathize with anyone who finds themselves perplexed at times about statistical principles. I like this quote from Neil deGrasse Tyson where he says that the human mind isn't wired to naturally comprehend probability and statistics. Interestingly, the more we learn about the way the brain works, the more convinced we become that the brain functions on the basis of probabilities and statistics. We just don't have a conscious way of making sense of that information, and certainly when it comes to statistics, it's not something that we inherit from our parents at birth. My feeling is that statistics is hard for most people, and that if we don't make a concerted effort to push through the challenging times and to try to do everything that we can to understand, we may find ourselves hitting what feels like a wall. But often that wall is just a steep learning curve that can be overcome with effort and with talking to people and with getting help. And we hope this workshop will be part of the solution for those of you who feel confused. I would also say that good researchers know how statistics work, but to take that a step further, I think it's also important to know why statistics work. Usually, learning how statistics works for me is a very mechanical thing. I learn it from a textbook, from a workshop, from a class, from practice, but understanding why statistics works comes in a different way for me. It comes after thinking deeply about my data and trying to understand how it is that I got data that I understand because I was the one that designed the study and collected it, and how that translated into the statistical results I have, and really trying to think about the big picture considerations that went into the statistics themselves. And often we can get by just knowing how statistics works and being able to click the buttons, type in a little bit of our code, and see the results. But I would encourage you to try throughout the course of your career to take that a step further. Whenever possible, try to internalize why it works. Why does this help to summarize your data? Why does it help you to draw conclusions about your data? And I found that as I ponder on those questions, light bulbs come on, and I'm able to make connections that I wouldn't have made if I would have just
accepted that I'll never know why it works, but only how. I think we can know both. They're just different types of knowledge that come in different ways. Okay. I think many researchers know just enough about statistics to be dangerous. They know enough to click buttons and to produce results on a page, but maybe not enough to actually explain their results or to even interpret them. Just the fact that you're here today shows that you want to go beyond that. And I think we have to make a choice to go beyond that and not simply accept that it's enough to click buttons, produce results in the same formulaic way that everybody else does in the field, and hope that nobody puts us on the spot and asks us what it all means. It's perfectly okay to say, I don't know. Any of my students will tell you that they hear me say, I don't know, regularly. When I teach statistics, almost every day, they'll ask a question. I look confused, and I say, I don't know, but let's find an answer. And I tell them, you spend some time before Wednesday, I'll spend some time before Wednesday, and let's come back together and make sure we try to come up with an answer to this question that's satisfactory. So it's okay to say, I don't know, except that you're not going to know everything about statistics ever. But it's not okay to stop there. And if a question matters for you, in order to understand your data, then don't stop with I don't know. Go as far as you need to find an answer. And most university campuses have a statistics department with a consultant